Hey there, fifth graders. We are going to do our Unit 1 review, adding and subtracting fractions. This is just our first unit review. We're going to be reviewing all week long, but this is the one that we're going to be doing together in class today in our small group time. So I thought I could walk through this with you. So you should have printed this out if you weren't at school today, or maybe you're solving these problems in your spiral. That would be fine as well. And you should try to complete them on your own first. So if you haven't done that, do that first, and then come back to this video and check your work, and then it'll be just like you didn't miss a thing. Okay, so the first section I ask you to compare using less than, greater than, or equal to, and we learn to ask ourselves some questions. The first question we learn to ask ourselves is, do the denominators match? No. And then we ask ourselves, do the numerators match? And in this case, it's yes. And if you recall, the lower the denominator when the numerators match, the lower the denominator, the larger the pieces. So 2 7ths means I'm only having to share with 7 people versus 8. 2 7ths would be greater. Now, if you did go ahead and make your denominator 56, you would see that this was greater, okay? And that is fine. If you wanted to make it 15 or 56, I don't mind at all. All right, for number 2, the denominators don't match, the numerators don't match. I can't multiply 8 by something to get 9. So I'm going to multiply each fraction by the opposite denominator. And for this one, I get 45 out of 72. And this one, I get 63 out of 72. And 63 out of 72 is greater. For number 3, the denominators don't match, the numerators don't match, but 3 is a factor of 12. I can just multiply the 3 by 4. And this would become 8 twelfths, which is greater than 7 twelfths. Now, if you multiplied this by 12 over 12 and this by 3 over 3 to get your answer, you're still going to get that this is greater, and I have no problem with that. All right, next set, write each as a mixed number. So with this one, I'm going to see 4 times what gets me closest to 13. I want to know how many 4/4 there are in 13. So 4, 8, 12, 3 groups of 4/4. I can pull 3 4/4. Now I'm at 12, right? 4 times 3 is 12. There's 1 left to get to 13, and my denominator doesn't change. So 3 1/4 is what you should have. For number 5, 3, 6, 9, 12, 15, 18. That's as close as I can get without going over. So 3 times 6 is 18, and then from 18 to 20, 18, 19, 20, that's 2 out of 3. For number 6, 2 times 9 is 18, and 18 is the closest to 19 without going over. And the difference between 19 and 18 is 1, and my denominator doesn't change. And for number 7, so close, but 5 times 5 is 25. 5 times 6 would be 30, that's too big. And 25 plus 4 is 29, so 5 4/5. And if you did set up the long division for this, it would look something like this. And you would see, okay, 5 is my whole number, there's 4 left, my denominator doesn't change. Okay, you didn't have to show me that, but if you did, it's A-okay. All right, for the next set, I want you to tell me whether each pair of fractions is equivalent. And remember, we can create equivalent fractions by multiplying or dividing the numerator and denominator by the same thing. So for number 8, I see 5 and 25, and I know that 5 times 5 is 25, and 6 times 5 is 30. So because I was able to multiply the numerator and denominator by the same thing and get that result, this would be a yes, those are equivalent. For number 9, I know that 10 plus 2 is 12 and 20 plus 2 is 22, but that's not how I create equivalent fractions. And I noticed that 10 20ths, isn't that equal to a half? Is 12 22nds equal to a half? No, I would need 12 over 24. So this is a no. I can't multiply the numerator and denominator by the same thing, and they both would not simplify down to 1/2, just the 10 20ths would. All right, for number 10, I know that, let's see, 7 times 1 is 7. Is 12 times 1 24? Nope, so that is a no. Those are not equivalent. For number 11, to get from 8 to 24, 8 times 3 is 24. And 9 times 3 is 27, so that would be a yes. So basically, if you could multiply or divide the numerator and denominator by the same thing to get that second fraction, it's a yes. And if not, it's a no. Okay, now just some regular old fraction problems to solve here. So I have 4/5 plus 2/3, and I will have them set up vertically on your assessment for you so you won't have to rewrite them. For this, I look and see my denominators don't match, and 3 is not a factor of 5. I can't multiply 3 by something to get 5. So I'm going to go ahead and multiply each fraction by the opposite fraction's denominator to get this set up. So my new fractions would be 12/15 plus 10/15. Now that my denominators match, I can bring it down. 12 plus 10 is 22. And the directions say to write your answer as a mixed number, so I don't want to leave this. That's improper. I know that 15 goes into 22 just one time. And so I'm at 15, right? 15 plus 7 is 22. And our denominator doesn't change. So 1 and 7/15 is what you should have. All right, number 13, my denominators don't match. 3 is not a factor of 4, so I'm going to have to multiply each fraction by the opposite fraction's denominator. And now I would have 9/12 minus 8/12, and 9 minus 8 is 1. My denominator stays, and there's nothing else I need to do. That one's good. All right, number 14, the denominators don't match. 4 is not a factor of 5, so I would have to multiply each of these fractions by the opposite fraction's denominator. This was a step I was noticing in class that a lot of people were kind of trying to condense down into one. I would highly suggest rewrite your whole number and then write the fraction that you get next to it, because a lot of people that skipped writing that whole number forgot about it entirely in their answer. So this is your new problem that you created. Now, I don't know if you noticed, but this is where I go, oh, because can I take 12 away from 5? No, you can't subtract backwards. You can't change the order. So I am going to have to ungroup the 6. So I borrowed one whole from the 6, right? One whole in this case would be 20/20ths. Now I'm going to rewrite this again. You should too. 5 and 25/20ths minus 3 and 12/20ths. Now we finally arrived. I have to do 25 minus 12, which is 13. And, oh, you know what? I just noticed, sorry, 4 times 4 is not 12. I saw that 3 right there. It's 16. Maybe you were thinking, oh, I caught you. Yeah, I know. It's early in the morning. So this right here shouldn't be a 13. This should be 25 minus 16 is 9/20ths. And 5 minus 3 is 2. So 2 and 9/20ths. I'm glad I caught that now instead of after. I've left some errors out there that I discovered at a later time. But I am making these videos really early in the morning and I haven't had all my coffee. That's my excuse. All right, next one, 1/2, 1/6, those don't match. So what do I need to do? I need to get denominators that match. And I notice that 2 is a factor of 6. So I can just multiply 1/2 by 3/3, and I end up with 3/6 plus 3 and 1/6. So 3/6 plus 1/6, 3 plus 1 is 4. And my denominator stays. And then I just have the 3 here. So 3 and 4/6. Or maybe you notice, hey, 2 goes into both of those. 4 divided by 2 is 2, 6 divided by 2 is 3. You could also say 3 and 2/3. That would be just fine. All right, we're on the back. Only a few more to go. A couple of word problems here. I like to call them math stories, because who doesn't like a good story, right? Okay, and again, we're writing our answers as mixed numbers. Chelsea is riding her bike on a path that is 7 5/6 miles long. She took a break after riding 4 7/12 miles. How much farther does she have to ride? So I know that the path is a total of 7 5/6 miles, and I gave you the part of how far she traveled. So if I want to know how much farther she has to ride, when you're given a total and a part, that means we're going to subtract to find that missing piece. So I would take that total, 7 5/6, and subtract how far she's already gone from it. That's your step 1. From here, I would ask myself, is 6 a factor of 12? And the answer is yes. So I can get away with just multiplying by 2/2. So I'd have 7 and 10/12 minus 4 and 7/12. 10 minus 7 is 3. 7 minus 4 is 3. So 3 and 3/12 would be just fine. Honestly, it would be fine if you had 72 on the bottom. Okay, that would change your numerator. But 3 and 3/12 could also be simplified to 3, and 3 goes into 3 once, 3 goes into 12 4 times. Either one of those would be fine. That's how far she has to go. I would accept either one, and I would also accept the 72 in the bottom. I think it's like 18 over 72. All right, number 17. Ashton's team spent 1/5 of practice time on defense and 1/8 of practice on offense. What fraction of practice time did the team spend on defense and offense? So that means I want to know all together. So we should be adding 1/5 and 1/8. 5 is not a factor of 8, so I would go ahead and I would multiply this by the opposite fractions denominator. And now I would have 8 over 40 plus 5 over 40. And 8 plus 5 is 13. So we'd have 13/40. That's how much time. Is that more or less than a half? Are you tired of me asking you that? It's less than a half because 20 out of 40 would be a half. All right, number 18, Maddie and Ellie. My daughter had all her friends over last night. They were very excited to get to star in the story problems. Maddie and Ellie shared a small pizza. Maddie ate 2/5 of the pizza, and Ellie ate half of the pizza. What fraction of the pizza did they eat? So I want to know together, right? That means we're going to add 2/5 plus 1/2. Those denominators do not match, and 2 is not a factor of 5. So I'm going to multiply each by the opposite fractions denominator. I now have 4/10 plus 5/10, which means they ate 9/10 of the pizza. Is that the whole pizza? No, it's 1/10 away from the whole pizza though. They had to leave that little slice in there. All right, number 19, Sierra and Trayson were racing around the block. At one point, Sierra was 5/6 of the way around the block, and Trayson was 3/4 of the way around the block. How much farther around the block was Sierra than Trayson? So I'm asking you for the difference between the two, right? If I want to know how much farther this is than this, I'm not going to add them. I want to know the difference between them. That means subtract. And if we know that Sierra was farther than Trayson, then we should start with Sierra's amount. So it would be 5/6 minus 3/4. Now, 4 is not a factor of 6, but this is one where you could use the LCM. And if you use 24, it's not wrong, okay? But I could use 12. I could multiply 5/6 by 2 over 2 and 3/4 by 3 over 3 and have 10/12 minus 9/12, which does give me 1/12. Now, if you multiply this by 4 over 4 and this by 3 over 3, you're just going to get 2 24ths instead, which is fine. It's not wrong. But 1/12 is just fine. All right, thank you so much for watching.